7.5. Solving radical equations. Solving radical equations is very much like solving any other equation. All we need to do is isolate the variable and solve for that variable. So say something like this. We know this is an equation. Why? Because it has an equal sign. So far we've just been dealing with radical expressions. Is this a radical expression? Well, I guess because we can set everything over 1, so we can make everything into a rational number. We can make everything into a fraction. So yeah, this is a rational equation. The ones that we're going to be dealing with are a little bit more difficult, but let's just start off with something easy like this. Something that we've seen before. I want to subtract 2x from both sides. So I have 2 equaling x minus 4. I want to isolate that x, so I'm adding 4 to both sides. 6 equals x, and we're done. People don't really like that, or like it in this form. They want to say x equals 6. That's totally fine. Did you like my little spin that I did? I know I did. Now this one has a fraction in it. So what we want to do is we want to multiply by the lowest common denominator. So we're just going to pretend that these guys are over 1. What's the lowest common denominator between 4, 1, and 1? It's 4. So we want to multiply each of these terms by 4, then we can get rid of this, this fraction right here. So I'm going to write everything down again. X over 4 plus 3 plus, equals 7. But I'm going to multiply everything by 4. So then this becomes, look at our canceling, folks, I love it. This becomes x plus 12 equals 27. Subtract 12 from either side. X equals 15. And put a box around it and we're done. This one's upping the ante just a little bit more because we have 2 different denominators. We have a 3 and a 4. The thing that we need to remember is we need to find our lowest common denominator and multiply it by it. The lowest common denominator in this is 12. So I'm going to multiply each of these terms by the lowest common denominator, and then we'll isolate n. So I'm just going to write the numbers again. 3, put them in brackets just to contain them. We don't have to do this, it just visually makes a little bit more sense. Let me just double check. Yeah, that is 13. And what I'm going to do is I'm going to go in and I'm going to multiply by the lowest common denominator. So times it by 12, times it by 12, and times it by 12. 3 goes into 12 4 times. 4 goes into 12 3 times. So let's rewrite it. 4m plus 9m equals 12 times 13 is 156. 13m equals 156. Divide both sides by 13, and I'm going to get m equaling 12. Put a box around it. In these scenarios, folks, we haven't had to consider what the non-permissible values are because, well, 3 can't be 0. Okay, it's 3. 4 can't be 0. Okay, it's 4. 1 can't be 0. Okay, it's 1. So we haven't had to deal with the non-permissible values because we haven't yet had any variables in the denominator that could make the denominator equal to 0. One last thing. So far, I said with these two, you multiply by the lowest common denominator. Think about it. What's the lowest common denominator between these guys, between these terms? That's right, it's 1. And I can multiply by 1 until I'm blue in the face, and it's going to be the exact same thing. So we did kind of do that step. We can just multiply through by 1, but it would just make it look exactly the same.